In this problem, it's a pre-lab problem, pre-lab 5 for the second week. We have this theoretical calculation that we need to do. We have a V0, a V2, a R0, an R1, and a delta R that we're going to use in our calculation. We're given this op amp and we need to make a simple, elegant equation for this if we were to have values we would solve for. So this is our op amp, and now we are going to do Kirchhoff's current law with it. So we have one node right here. It's going to be Vn for negative. We have one node right here, Vp, for positive. And we know that Vn is equivalent to Vp. So we're going to keep that in mind when we write this equation. When we look at our Vn, we know that we have some current going over this resistor. Because of negative feedback, we have some current going over this way. And then for our Vp, we have some current going this way, down this way, and then we have some going this way. And so what we can do is say, well, let's solve for our Vn first. Our Vn is going to be Vn minus our V2, and this is all happening over our R1. Then, because of the negative feedback, we have Vn minus V0, and this is all over the R plus delta R. This is equal to 0. Now notice in here, we have our V delta, or I'm sorry, our V0, V2, R0, R1, and R delta, but we don't have a Vn in here. So what we're going to have to do is get rid of this Vn. That means the next equation that we make with the next node, we're going to substitute it in once we find our Vn. So in here, for the next equation, we're going to have Vp minus our V2, and this is all happening over our R1. We will have a plus Vp, and then this is actually just going to be over our R0, set equal to 0. Now, due to these equations, since this one's smaller, I'm going to use it to plug into here. So we're going to solve for our Vn, which we know is our Vp. So what I'm going to do is I'm going to substitute Vn for the Vp right now. That way we can see things a little bit easier. So inside of here, we're going to have a Vn. We are going to have 1 over our R1. We are going to have it be plus 1 over our R0. And this is equal to a V2 divided by our R1. And we can simplify this a little bit. We'll simplify everything inside of these brackets. We are going to have Vn. We are going to have R1 plus R0 divided by R1, R0. And then in these brackets we have R2, R1. And then finally we can say that we have a Vn equal to V2, and then this is going to be, since this is R1, when we divide these, this is going to be on top, and this is going to be on bottom. We're going to have an R0 on top, and then a R1 plus R0 on the bottom. And so this is going to be our V of n. And now we can just plug this back into our equation. So plugging back into our equation right here, we are going to have a V2 R0 over R1 plus R0 minus, and then we can actually just move this into this part and then this part. So what we're going to actually have is this being multiplied by our R1. Then we have a minus V2, and this is all over our R1. And then from here, we are going to, it actually might be better if we combine these. So we have this as our current part right here, and that's this part. So instead of having it like this, well, let's make them have the common denominator. So what we're going to do is we'll keep this until we combine them. So in here, we're going to extend this. The denominator is going to be the same. We're just going to have a minus V2. This is going to be multiplied by the R1 plus R0. And so that's our common denominator, and now we can erase this. We no longer need it. And then from here, we can just set this equal to, and we're going to move this to the right because we need to solve for our V0 eventually. We need to get it by itself. So inside of here, we are going to have the V2 R0 over our R1 plus our R0. And then this is going to be over the R plus delta R, but what we can do is we could just put it in here, so R plus delta R. And so that's that. Then we have, like earlier, minus V naught divided by the denominator R plus delta R. And then inside of here, we are going to have just this, actually. So this is just going to be this part right here. We want to have a common denominator, so what we're going to do is, just like what we did earlier, we're going to have a minus, and then we have our V naught, and then we have parenthesis, and then we're just going to have this in the numerator because we have to multiply both the top and the denominator by it to have the same denominator. So we have minus V naught, and then we have R1 plus R naught. And I did make a slight mistake. We're going to erase this first, and then we're going to deal with it. The slight mistake is that when we move this over, we are actually subtracting it. That way we can subtract it from this side and then subtract it from this side. But that means this should be a negative and this should be a positive because we have to switch the signs. Now we can solve for this. Well, we can see that this is going to cancel out with this on both sides. And then from here, what we can do is we're going to take this R1 and we're going to divide it into this part. And then we can take this and multiply it onto this side. We're going to do those two in two separate steps. So coming down here, we are going to have a V2, we are going to have a R0 over R1, and then we're going to have a minus, and this is a R1 over R1. So actually, we can just factor out our V2 too, just to make things simpler. We're going to factor out this V2 and this V2 out here. So this is going to be out here, and then we're going to have an R1 over R1, so we'll have a minus 1, and then we will have a minus R0 over R1, because when we factor this out, we still have to distribute this negative in. And so that's going to be that part. And then we can multiply this by our R plus delta R. And this is going to be equal to a minus V2 R0 plus the V delta, or I'm sorry, V naught R1 plus R0. And then from here, we can see that these are going to zero out with each other. And so we're going to have a negative V2, and then we will have, because of this negative one, by the way, and then we're going to have an R plus delta R. And then we can add this to both sides, so we're going to have a plus R0, and then we can actually just put this in brackets and factor out the V2. That's where the V2 went, by the way. And then, well, we can just divide both sides by R1 plus R0. And this is going to be equal to our V0. Now, I did make a mistake here though. When we factor this over, we're adding to both sides. So we can't just put it inside of here because you see we have this negative out here. We can't just factor that in. So that will be incorrect. So we're going to rewrite that because that's actually a pretty big mistake. So on the left side, we have our negative V2, like this. We have our R plus delta R. And then we're going to have a plus V2 R0. And another mistake that I made stems all the way back from when we wrote this out here. We have this R0 plus the delta R. However, we don't have an R0 in here. So we should have an R0 there, R0 there. And then if we look over this, we will have an R0 here. So that is another huge mistake that I made. So we should have an R0 here. And so this will make a little bit more sense when we add these together. So this is going to be equal to a V0. We've brought this over to the left side. That's what this is. And then we're going to divide both sides by this part. So we are going to have this all over our R1 plus our R0. Now, we can combine the numerator together. We have a, and actually let's factor in this negative real quick. We have a V2 minus our R0 minus our delta R, and then we'll factor out the V2, so we'll have a plus R0. And then this is over our R1 plus R0, and this is equal to V0. And then from here, well, this will zero out with this. And so our simplest form, and we'll just write it out in green, is going to be as follows. We'll have a negative V2, we'll have a delta R, and this is all going to be divided by our R1 plus our R0, and this is set equal to our V0. So that is the final simplified and correct equation for this problem. First, we looked at this red node, the Vn, then we looked at this Vp. Since the Vp was smaller, we used this to plug into our Vn up here. That gave us this in black, and then we continued on simplifying for it down here, and then we finally got our answer. And so that is how you would go about doing this problem.